Okay, so geometric series. Let's write some stuff here. So sum of all the terms, or I should say of all of the terms. Let's just say of the terms and cross out all. Sum of the terms of a geometric sequence. It can be separated by plus or minus signs. Right? If your common ratio isn't negative, that's when it could be separated by a minus sign, or just your values are negative. So instead of having, like sometimes they might write it like, so for this, you might see it this way, this very first example, or you might see it as 2 plus -4, plus 8, plus -16. That's the same thing, right? They can write it either way, so don't be confused if you see minus signs. It means the exact same thing, okay? So let's look at this sequence right here. 1, 3, 9, 27, 81, and 729. If we use our calculator and we added those together, you could do that. So I just wrote down the answer, 1093, right? We know how to add terms together. That's okay, again, if we're adding only a small amount of terms. If we want to sum 50 terms in a geometric sequence, that's a waste of our time. It's very cumbersome. So we need two formulas. Now, if you want to see how these are derived, I'm not going to take you through them. It's not necessarily, you don't have to know exactly how to prove them. So if you want to read through it, it's on page 48 of your textbook. Okay. So you'll notice that to get those, how they are derived, okay? So these are the two formulas that are on your formula sheet for the sum of a geometric sequence. In the first one, notice you need to know your first term. I'll make this a little larger. Okay. So T1 you need to know your common ratio and the number of terms. Those three things, and then you can find a sum. The second formula is very interesting. If you know your last term, your first term, and your common ratio, you can find the sum of the sequence, which is very different from arithmetic, because when we were solving arithmetic series, we always had to know the number of terms. So if we didn't know it, we had to go back and solve for it. The nice thing about the second formula, as long as you know your last term, it doesn't matter. You don't have to know the number of terms. So you don't have to know n. This is the only formula that you don't need to know n. Well, and the infinite one. Okay? So let's determine the sum of these first terms. Okay, let's see what we have. What do we know here? First 10 terms. We know T1, which is 4. We know our common ratio is 3. Multiplying by 3 each time. And do we know our last term or the number of terms? Number of terms is 10. So because we know the number of terms, then we're going to use the very first formula. Okay, you do not need to memorize these formulas. That's what your formula sheet is for. Okay, so let's just plug her in. Sum of the first 10 terms equals your first term, 4, times common ratio of 3, power of 10, minus 1, all over 3 minus 1. Now, if you're typing this in your calculator and your calculator is not updated, the 84 silvers, you can actually update them. So if yours doesn't have a lot of the features that other people's 84 silvers does, so then you can actually update it. You need the code and you need to go onto the TI website. But if you just have like an 83 calculator, TI 83, then you need to make sure to have brackets around your denominator, right? The nice thing about if your calculator is updated, you can go alpha y equals, right? If you can go alpha y equals, your life is good because it has the numerator over denominator option. You might also have that in the math. You push math, if there's a fifth column, like mine doesn't. There's different updates, but it might be the very last, like mine's only showing 4 different categories up top. There's 5. Okay. So the nice thing about that, you're more likely not to make a mistake when you type this in. You can type it exactly how you see it. I'll type it in the other way later. Okay, minus 1, and then 3 minus 1. And I don't need brackets around the 3 minus 1 on the denominator because it's already set up as numerator over denominator. So if you have that option, use it. Alpha, y equals. If you don't have that option, you just need to be careful. So when I type this in, 3 to the power of 10 minus 1, and then divided by, I would need brackets, 3 minus 1, or it's not very hard to subtract 1 from a number, so you could just divide by 2, right? You can do that in your head. You just have to be careful. If you want to type it in all at once, you need brackets around your denominator. 118,096. So careful when entering in your calculator. Okay, this guy. What do we know? First term is 4. Common ratio is what? -4. It would be -4. Right? Because the signs are switching each time. We don't know the number of terms, but we do know T of n, our last term. So we have to use the second formula. See, if this was an arithmetic sequence, we'd have to go back, solve for n first, and then use the sum formula. That's the nice thing about the geometric. We don't need to know the number of terms. R is -4 times the last term minus the first term all over R minus 1. So again, you need to be very careful. If you can use numerator over denominator, do that. Otherwise, you need to use brackets. -4, close my numerator brackets, divided by, open my denominator. So you don't have to worry about wrapping it in brackets if it is, if you have numerator over denominator. Okay, so alpha y equals, typed it in that way. You could also type it in like this. Okay. Can you see that all right? I could dim the lights if we have to, but then it gets super dark in here. There's like no happy medium in this room. It's dark or it's light. -52,428 would be your sum. Okay. Unfortunately, they're not always going to be that straightforward, though, are they? So let's do a couple word problems. And we're going to also do some bouncy ball problems. Yay! Told you we like bouncy balls. Good? Question?
Not the same answer.
Yeah?
Of 428, I don't 432.
Oh. Did I type something wrong, or did you type something wrong? Let's see, 36. 65536 -4 is your first term. Oh, +4 is your first term. Right? So let's see. No, your common ratio is -4. Yeah. First term's -4. Did anyone else get 32? You might have typed in a number wrong. Like check the 65,536. That's right. The first term on here, on mine, because of the minus term 1 though. Okay, 1 second. Let me pause this. A tournament involving chess players has 256 entrants. In each round, 2 players compete, and the loser is eliminated while the winner goes on to play. This goes on until a final match determines the champion. How many matches will be played in the tournament altogether? So let's start with making a sequence here. So in round 1, because we're looking for how many matches altogether. So let's make the number of matches or the number of games in each round our term number, our terms. So in round 1, how many matches are played? How many games are played? If there's 256 people, how many games will be played at once? You need 2 people to play a game. 128. So you'd be playing 128. So this is the number of games or matches. A match is the same thing as a game, right? 2 people need to play them. Okay, so in the second round, round 2, how many games would be played? 64, because half those people from before got eliminated. Now there's half as many people, and so forth. Okay, this would keep going until what happens? There's 2 people left, which means how many games are left? The very final game? 1 final game. The final match. So, this one's asking how many matches will be played all together. First of all, term 1 is 128. What's the common ratio? 1/2 or 0.5. Okay. And we're looking for how many matches will be played all together. So we're looking for this sum, right? So we want to add all these games together. So we're looking for the sum. Do we know anything else? The last term is 1. So we can use the second formula, RT of n minus term 1 all over r minus 1. So you can use 0.5 or 1/2. It's up to you for your r. 1/2 times 1 minus the first term divided by 1/2 minus 1. So use numerator over denominator, or you need brackets around your numerator and brackets around your denominator. So 1/2 times 1 minus 128 divided by 1/2 minus 1. Make sure you get the same answer. How many matches did the winning player have to play? So now what are we looking for? How many matches did the winning player have to play? How would I figure that out? The winning player, are they playing in every single round? If you're the ultimate winner? Or did you play in every single round? You had to. Because it's an elimination. So you win this one, then you go on to the next round, or you're eliminated altogether. You want to find the number terms. That's all you need to find. Yeah? There's no buys here. Because that would make it so complicated. No, there's no losers here. It's like, you lose once, you're out. Sorry. Yeah, there's no like consolation prize or thanks for showing up to like ribbon. You have to win them all. Yeah. Tough love here. Okay, so we know we want the number of terms. First term is 120. Sorry, first term is 128, and our last term is still 1. Now this is fun. We're not using the sum formula, right? Because it's not looking for us to sum. We're just looking for the number of terms. We're going to go back to this one. This is where you're all going to groan. Because we have to work with fractions. Yay! Okay, T of n. No, you can't. It's going to make your life harder, I promise. Times 1/2 to the power of n minus 1. So, we want to solve for the exponent. What did we do yesterday? First step. Isolate the base. So 1/2. Well, yeah, because we can't really isolate an exponent. So the only way we're going to be able to kind of isolate the exponent is to isolate the base with the exponent. So we're dividing both sides by 128. Yay! So we have 1 over 128 equals 1/2 to the power of n minus 1. Do you remember what we did yesterday? Yeah? So we want the bases to be the same. We want them to be equal. So we need to figure out 1/2 to the power of something has to equal 1 over 28. Yeah, so we want to figure out what would be the exponent that would give you 1 over 128. Now, you just need to guess and check with your 2's. You don't actually have to put in 1/2 to the power. Because 1 to the power of anything, it's still going to be 1. Your numerator's not changing. It's just our denominator. So to make things easier, you can guess and check with just 2. 2 to the power of 6. Nope. 2 to the power of 7. Yeah. So that means 1/2 to the power of 7 is the same thing as 1 over 128. 7. So therefore, what is n? 7 equals n minus 1. It's 8. So the ultimate winner played in 8 games, 8 matches. So did the loser, the second place person. Yeah. Hey, if the tournament had 512 participants, how many matches will be played? Now, you don't have to go through all that math again. There's an easy way. You just need to think. You just add one more round. Why? If you double the people, this is doubled, then we're just adding an extra round to eliminate it back to the original 256. So if we added one more round, how many matches will be played? 9. Yeah. So 9 rounds. Since we doubled the players, the original number of players. You only need one extra round to eliminate half of those people. And then you'd be back at 256. Yep. Oh, sorry. It's the same thing. Matches. Is that different? Is that different?
Yeah, it says each round, 2 players. That's
Oh, yeah, okay. Well, yeah. Well, no, then we play in each round, too.
It's
It's asking
asking for
for what?
It's asking for everybody, not just each
Oh. How many matches will be played? I meant rounds. I meant rounds. Because that would be a whole another question. Because then half the people are playing in one, right, in the beginning. And oh, yeah. So I meant rounds, sorry. Yeah, let's say round. That's what I wanted to get across. I didn't want to figure out how many, like, each person, like, how many total. Yeah. That's doable. You're welcome to solve it. I'm good. Okay, let's move on. Last page. So everything up to page 13, lucky number 13, is on your quiz. Am I recording still? I forgot. Yeah, okay. I'm gonna make this smaller. Joe begins by calling 3 people. Then those each call 3 other people. This is what they call a pyramid scheme. And so on. If 8 call-outs are completed, how many people would be contacted in total? Or like a chain letter, right? It's like, if you send this to 3 people, then you'll find true love. And if you don't, you're going to die a horrible death. Something like that. No? Yeah. Chain letters. Don't believe them. They're ridiculous. Okay. Joe begins by calling 3 people. So they're asking for us how many people will be contacted in total. Nope. Nope. Good guess, though. What did you say, 6,000? More than that. Okay, so how many are contacted the first call out? 3, right? The very first call out, 3 people are contacted. 3. Right? Because Joe wasn't contacted. Joe is like the brilliant mind behind this beautiful scheme. Then those 3 people call 3 people, which would then be how many the second round are called? 9 new people, new amount of people. 9, right? 3, 3, and 3. And if we follow this part, then the next round would have been 3 more for this guy, and so forth. Would be 9 times 3, or 27. And we want to know how many total people are contacted. Is this a sequence or a series? Series, because we want to know total number of people that will be contacted after how many call-outs. So this was first call-out that Joe made. And so we want how many? The 8th call-out. The 8th call-out would be term what? Term 8. Okay, you can solve that, right? Why don't you try it? It's all set. The stage is set. You can do it. Term 1 is 3 times 3 to the power of 8 minus 1 over 3 minus 1. You should get 9,840. Okay? If the question, it depends how you word the question. If the question requires you to include Joe, then you would add 1. And you'd add 1 to your answer, right? For some reason, they worded it in such a way that you wanted everyone, including Joe, not just the people contacted, but all people involved in the telephone scheme. That includes Joe. You could also just remake your sequence. So your first term is 1, Joe. Second term is 3, and then go from there. But then your 8th call out would be the 9th term. So just be careful with that. But this one doesn't want us. It's just how many people are contacted. Joe wasn't contacted. He's the ringleader. Okay, one more bouncy ball question. They're back. I told you we love these. They're so fun, right? Oh man, this is just like your quiz question. Except for not. But I didn't mean to make them the same. Okay, a bouncy ball is dropped from a height of 10 meters. 10 meters. After each bounce, the ball rebounds 70% of its height of the previous bounce. Determine the total vertical distance. Very different. The ball will have traveled once it hits the ground for the 8th time. So let's draw that out. So we want to hit the ground the 8th time. That's 1, 2, 3, 4, 5, 6, 7, 8. Now there's 2 ways to set this up. Just kind of the same idea. There was 2 ways here, up and down. Same thing here. Say it. Say it. No? You sure? I just didn't hear you. Oops. I wanted to move my 10, but... Okay. So, here's the thing. I still like to make after the first bounce my first term. That's my preference. It's really up to you. It's also, if we want total vertical distance, we want the total distance up and down. Okay? So we want total vertical distance that it's traveled, up and down. Okay, so there's 2 ways to solve this. If we make our ups our first term, like we're used to, like what we did in the, I don't know, I prefer that. I'll show you both ways. So if this second, after the first bounce, I'm going to make that term 1. Okay? So if I do that, if 7 meters is my, I'm going to make my, if I just make my ups. So term 1 is 7. Then how many terms do we have here? So this would be term 1, 2, 3. How many ups are there? How many times did it travel up? 7. Can't read that, can you? Let me zoom in. Zoom. Is that better? So 1, 2, 3, 4, 5, 6, 7. There's 7 times that it bounced up. So n is 7. Okay. Common ratio is 0.7. Look at all these 7s. Okay. So if I want the total vertical distance, I want to sum together all my ups. Term 1 plus term 2 plus term 3 plus term 4, and I'll add those all together. Now the cool thing is, when it goes up, it also must go down. So once I find the sum of all the ups, how can I get the sum of all the ups and downs together? Yes, times it by 2. Because when it went up, it went down as well. So we can just double it. And then at the very end, what would we need to still include? The 10 meters, because that wasn't included in this. So I need to add on 10. So my total vertical distance formula I know distance does not start with an S. Try that again. There we go. Equals 2 times S7, so the sum of the 7 ups times 2 plus my original 10. Okay? So we need to find S7, double it, add 10. There's our answer of our total vertical distance. Okay? So let's find S7 first. We have to use which formula? We don't know our last term. Whoop. That's 7 times 0.7 to the power of 7 minus 1 divided by 0.7 minus 1. Okay, you should have 21.4117, so forth. Okay. Now that's not our final answer, so we don't want to round that yet. So now we have to do what to that? Double it. So it's 27.4117 dot dot dot. So we're going to get our total V, vertical distance, by doubling it. Oh, is it 21? Thank you. 2 times the 21.4117, and then adding on the 10. So times it by 2, and then add 10. And let's add, usually I'll say answer to 2 decimal places, unless it's a numeric response, then it probably would be 1 decimal place, but let's go to 2 decimal places. So 52.82. Okay. I'm going to show you really quickly, if you prefer to make your first term the 10 meters instead of the after the first bounce. Okay, so if I made, I'll do it in green. If I made the first bounce, I'm going to do all my downs. Okay, so then my first term would be 10 meters. Okay, now if I'm doing all my downs, then I want to draw this out and count 4, 5, 6, 7, 8. So we're looking at N8. There's 8 times that the ball went down. So 8 terms. Common ratio is still 0.7. But when we make the total vertical distance formula, there's one major difference. So again, what comes out must go down. I'm going to double my sum, S of 8, but instead of adding 10, what do I have to do? If I included the 10 meters and then I double it, I have to subtract off that 10, because then I would have included an extra 10 meters up and down, right? So that would be the difference. It would give you the same answer in the end. So you'd find S8, which would have been term 1 times your common ratio to the power of 8 minus 1, 0.7 minus 1. So that would work out to be 31.41173 dot dot dot. And so your total vertical, if you double that and subtract 10, guess what it equals? The same thing. So that's another reason why I like to always start my first term after the first bounce, because then we double it, ups and downs, and then add on that first drop. I find that makes more sense to me, but it's really up to you which method you use. And that's it. We are done now. We made it. And with time to spare. Ish. Okay.